Yesterday you were given the quick check problem. Shrek is being rescheduled at Dodgen on July 4th, 2020. Now it probably is not rescheduled for July 4th, 2020 because that's obviously right in the middle of the summer. And I have not heard anything about when or if it may be rescheduled. I hope so because I was looking forward to coming to see it. You have been asked to help create handwritten tickets for those who paid and confirmed they will be present on July 4th. Dr. Alford tells us there has been $1,615 collected, and Dodgen sold 198 tickets. If adult tickets cost $10 and student tickets cost $5, how many students will be present at the play? Well, if I was solving this problem, I would gravitate first to these numbers that deal with cost, because those are going to help me identify something real quick and easy. The total cost. Well, if an adult ticket costs $10, I'm going to have $10 times each adult. And if a student ticket costs $5, I'm going to have $5 times each student. Now, we talked about in class, when would I see variables other than X and Y? Well, this would be a good example of when I would see a variable other than X and Y, because I'm less interested in what X and Y is. I'm not going to try to graph this, at least not quite yet. I'm more interested in knowing quantities of how many adults or how many students. So if it costs $10 per adult and it costs $5 per student, and I were to add up the amount of money collected from adults and the amount of money collected from students, that should total this value of $1,615. Okay, so we've used that number, we've used that number, we've used that number. Let's go back through and figure out what numbers we haven't used. July 4th, well, that's not really relevant to setting up a system of equation. But we do see 198 tickets. Before I deal with the 198, let's talk real quick about what our variables represent. A represents an adult ticket. And S represents a student ticket. So if A represents the adult ticket and S represents the student ticket, and I were to add the quantity of adult tickets to the quantity of student tickets, well, then I should be able to figure out how many tickets were sold. But we were already told how many tickets were sold, so I can certainly say that A, the number of adult tickets, plus S, the number of student tickets, is going to be equal to the quantity of tickets sold. Well, I see that I have some leading coefficients that are 1. You have two options at this point. Graphing does not look like a good option. And I saw that we had some questions about when is graphing not a good option. Well, this would be a great example of when graphing is not a good option. Because if I try to graph this, I'm going to end up graphing 198 on your coordinate plane and 1,615 on the coordinate plane. And those are going to be kind of hard to figure out where they are, especially since most typical coordinate planes are 1 through 10 that we use in class. And your graph paper doesn't go that high. Now, certainly you could skip values, but once you start skipping values, figuring out exactly where 198 goes and where 1615 go and all these various numbers is going to be a little challenging. But I do see a different method, maybe the systems method. That seems like it would be relatively easy here. I just need to find an opposite coefficient. Well, I don't have any opposite coefficients, but I could very easily multiply one of these two terms by the opposite value above to be able to end up with an opposite coefficient. Now, I'm going to go ahead and tell you I'm going to use this one here because it's a smaller value. Actually, no, I'm not. I'm going to use this one here because it's a 10 and it's far quicker to multiply by 10s. So, A times negative 10 would be negative 10A S times negative 10 would be negative 10S. 10 times 198 is going to be negative 1980. So now for the time being, I'm not going to use this equation. I'm going to use its equivalents. And so we have 10 plus negative 10, which equals 0. We have 5 plus negative 10, which equals negative 5S. And we have 1615 plus negative 1980, which gives us negative 365. Well, now we're down to a one-step equation. We're going to divide by negative 5. And S is equal to 73. Well, we've just determined that we've sold 73 student tickets. Well, if I've sold 73 student tickets, how many students will be at the play? That's right, 73. Now, we could also go on to figure out the quantity of adult tickets, and that would be as simple as taking the 73 and plugging it in to one of our equations. So that would look something like adult plus the 73 student tickets would equal 198. And again, this is just a one-step equation, so we would subtract 73 from both sides. And the number of adult tickets would be 125. Well, this is real-world information. You might go on to ask, how much money am I going to make from inviting adults to the play? Well, then I would say 125 times 10. So that would be 1,250. You might also ask, how much money am I going to make from inviting students to the play? Well, that would be 73 times 5, which would be $365. So when we're doing an evaluation of where we end up making more money from doing this particular play, we're making way more money inviting parents to the play. Let's think about possible reasons why that might be. Well, one reason is you might have more parents than you have siblings, because you have some students that have no siblings. You have other students that have siblings that their parents chose not to bring them to the play. Another reason is you may have grandparents that would be attending the play. Now, certainly all of this is conjecture, but when you're in the real world trying to evaluate cost analysis of putting on events, these kind of projections can be beneficial.